Hello, welcome to Zigmatech Learning Hub. I will be your instructor for chemistry. For this class, we are going to be taking our exercises from the ExamGuide app. If you don't have the application already installed on your device or on your phone, I will want you to download the app in order to follow along in this class. ExamGuide is a leading educational app that helps students prepare adequately for various exams like UTME, post-UTME, WEAC, JCE, KCPE, IJMB, JUPEB, KCPE, BECE, JSCE, NCEE, NECO, etc. You can download the app from www.examguide.com or Google Play Store. Please subscribe to our channel and turn on the notification bell to be updated on new videos. Ready for today's class? Okay, let's get started. Now, in this lesson for today, we are going to talk about the classes of matter, part 1. Remember, we've talked about the states of matter. Now, these are the classes of matter. Now, for your objective, by the end of this chapter, you will know about the classification of matter. How is matter being classified? Now, matter, as we know, is being classified basically on its particular states it exists. Okay? Now, if the matter is being married or single, don't mind me, I call them single matters. Like the elements, I call it the single matter. You know, while the compound mixtures, I call them married matter. So, the classes of matter are basically bound on how this matter is being made, on how this matter possesses its occupation, as in how the matter possesses the place it occupies. Its occupation means how it reacts. Okay? Either it doesn't react in a chemical form or it reacts in a physical form. Okay? Now, substances include the classification of matter. How matter has been classified into substances, how substances have been classified under matter is the issue on how we classify matter. You know, things that occupy spaces must have classes. Like example, you go to school, okay? You're in JS1, that is your class. The next person is in JS2, that is his class. The next person is in JS2, that is his class. Now, depending on the year you spent will determine the class you're going to be at a particular point in time. If you spend 2 years in the secondary school, you're going to be in JS2. If you spend 3 years in secondary school, you're going to be in JS3. That's the same thing that matter is being classified. How does this matter undergo its changes determine the class of matter is going to be? How does this matter has its characteristics? The way the matter exhibits its characteristics will depend on the way the class of matter is going to be. Now, let us know the classes of matter, how matter is being classified. Now, matter is being classified as elements, you can call it the chemical element too, compounds, and mixtures. As you can see the illustration, element, compound, and mixture. I told you the kind of changes it undergoes determine the class, the kind of properties it has determine the class. Now, if you can see mixture, can it be physically separated? They said yes. That is its property. While for the pure substance, they said no. Now, the compound and the elements are called pure substances. You know what a pure substance is as we are going further, because they have a constant composition. Their composition is constant. Okay, if you have two atoms of hydrogen reacting with one molecule of oxygen to give you water, in the product, it is still 2 atoms of hydrogen. It does not change. While in the mixture, as you know, the salt and water, everything is going to become one. But we'll know that basically when we are going forward in this lesson. So relax, okay? You're going to get every detail. Now, if you check in the composition, homogeneous mixtures and so on, colloids and suspensions. So these are the classes of matter, the elements, the compound, and the mixture. Now, let's start with the element, okay? Now, the element, elements are fundamental materials, okay, that make up matter. Okay, these are the fundamental things that make up matter. In a literal or in a normal definition, like we'll say, elements are things that make up a particular substance. Okay, let's take for example bread. The elements in bread might be butter, flour, sugar, and so on. These are the elements in bread. You know, these are the physical elements. Now, in these elements, we are talking about the chemical elements. Okay, the chemical element, that is what we are talking about. Now, Aristotle brought out an innovation and told us that life or nature is made up of 4 elements, which is water, air, fire, and heat. Water, air, fire, and earth. Water, air, fire, and earth. These are the things he told us. And if you check it constructively, he is correct. Because everything you see in life is either air, water, heat from fire, or the earth. So these are the things he came off with an innovation with. Okay, the heat from the fire, the moisture from the air and water. These are the things the air we breathe are all made up of elements. Now, but Robert Boyle in 1661 understood the fundamental characteristics of an element when he made a scrutiny by heating and cooling of an element and came to see that the element cannot be scattered. That is when he defined an element. But if you check on your screen there, you see the first 20 elements. Okay, which is the helium, the hydrogen, the helium, the lithium, the beryllium, the boron, the carbon, the nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon, potassium, and calcium. Now, this H you see are the chemical symbols, okay, are their chemical formula. A chemical formula is a representation of elements with symbols. That H there is a symbol of hydrogen. In essence, it is the chemical formula for hydrogen. Now, that one you're seeing there is the atomic number. The atomic number is the number of protons in one molecule of an element. In essence, each molecule of hydrogen contains 1 proton. Each molecule of helium contains 2 protons. So this is how the chemical elements operates. Okay? So this is the first 20 elements. Now, when you check there, you see chlorine at number 17. Why I want to talk about chlorine is because chlorine is a non-metal that reacts with metal. It readily is a friend to all metals in the period as an element. Every element reacts with chlorine. Okay? Take for example, sodium is a metal. And the sodium reacts with chlorine to give you sodium chloride, which is the common salt we use in our houses. So chlorine, as we may know, chlorine, as we have seen, is a friend. He is ready, always ready to react with metals. He's a non-metal, but he's always ready to react with metals. That's why the next one is oxygen and fluorine. Fluorine too does that, but the main one is chlorine. Now, what is an element? Let's see what an element is. But before we see what an element is, we must have to talk about something. There are some elements in this first 20 elements that exist in 2 physical states at the same time. They can exist in 2 physical states. Okay? They can exist in 2 physical states. Example is the oxygen. The oxygen is a gas. Okay? And it can exist as a liquid when it reacts with hydrogen. It can still exist as a liquid when it's being put inside a liquid. So in this context, the oxygen himself can exist in 2 physical states. And when this is done, it's called allotropy. is called allotropy. Now, what is allotropy? Allotropy is when an element exists in two forms in the same physical state. Example, oxygen, sulfur, phosphorus. Sulfur is a gas, but it turns a liquid when it's reacted with hydrogen and oxygen. Sulfuric acid. So these elements that exist in two forms, okay, in two forms, okay, in the same physical state. Water, liquid is a physical state of matter. Gas is a physical state of matter. So they exist in these two physical states. They can exist in these two physical states. Okay? And sometimes they exist as solids. Let's take, for example, mercury. Mercury is a liquid, but at room temperature it becomes a solid. So these are how elements operate. So it is called allotropy. Now, I told you that note that it shows the same chemical properties, but they are different in their physical properties. How? The oxygen is a gas. Okay? It becomes different when reacted with hydrogen to become water. So in essence, it has become different from its real physical state of matter. From gas to liquid. Now, what is an element? A chemical element or an element is a substance that cannot be further broken down by any chemical reaction. There's no chemical reaction that has been proven that can break an element. Now, take for example, you're eating bread or you're eating meat pie, and a particle of the bread falls on the ground. It's not because of the meat pie or the particle of bread falls on the ground that meat or that particle will change to stone, or it will change to rice. It will still become bread. I'm just giving you a physical explanation of element. It will still become bread. So if you want to tell a younger brother to pick, you tell him, pick that bread on the ground. That's what you tell him. Or pick that particle of bread. You will call it bread. So in that place, there is no process that will change that particular bread to another thing. It's like Gary. Rice. A grain of rice falls on the ground. And when the grain of rice falls on the ground, you pick it. When you pick it, it will change to beans. It's not possible. That is how an element is. There is no reaction that can scatter an element. Anyhow you break it, anyhow you scatter it, it will still become that particular element. The particle of that element will still be the element. Okay? So, this is what an element is. Anything that cannot be further broken down by a chemical reaction is an element. Substance there means anything. Now, classes of elements. Elements are classified into metals, non-metals, and semi-metals. The semi-metals are called metalloids. Now, check around us. There are three things. Okay? There are three things that makes us going. Physically, as in the non-living things. That's what I mean. Okay? These non-living things, they are either metals, non-metals, or metalloids. In essence, elements are non-living things. Because the metal is non-living, the non-metal is non-living, and the semi-metals are non-living. So they are non-living things. Okay? But they are mostly natural. There are some elements that are natural and there are some elements that are artificial. But no matter how they are natural, they are still non-living things. Now, we'll talk about more about elements when we get to the periodic table. Okay? We'll talk about more on elements when we get to the periodic table. That's when you know more of elements. The man that discovered the elements, the people that discover the elements, because every single element has somebody that discovered it. We'll talk about that, about the 118 elements that is existing. So now, number one, let's talk about metals. Metals. A metal is any material that readily forms ionic bonds and has metallic ions. I give an example there as copper, silver, iron, and gold. They said a metal is any material that readily forms ionic bond and has metallic ions. Now, ionic bond simply means the bonding of charges. Okay? The coming together of charges. We'll know what ionic bond is basically, constructively, when we get to chemical combination, when we're talking about covalent, ionic, and electro, and all those things. So in this context, let me just explain briefly. Ionic bond is just the bonding of electric charges. Ions there means electric charges. The ions there are charges. Okay, so this ionic bonds means bonding of electric charges. Now, the copper bonds electric charges. Okay, the copper accepts electric charges. Okay, the copper allows electric charges to flow through him. The copper allows electricity. That's what I mean. Ionic there means charges, like I said, and charges are electricity, electrical current. Okay, it allows electricity to flow through it. That is why it is a conductor. Now, they say it has metallic ions. Metallic ions are the bonds or relationship between two metals. Okay, relationship between two metals coming together to form a bond, coming together to form charges. Okay, let's take for example copper and aluminum. When you put them together, they will definitely form charges because both of them are positively charged. The positive charge ions still have a little bit of electrons. So they will form charges. They will definitely form charges when they have these metallic ions. Now, example like copper, gold, silver, aluminum, and zinc. Now, if I put a copper that is charged on an aluminum, it will form a metallic bond. But there will be a transfer of current from the gold or from the copper to the aluminum. There will be a transfer of current. So in essence, they bond together. Now, let's know what a non-metal is. A non-metal, we'll talk about metals more when we get to metals and their compound. Now, let's go to a non-metal. A non-metal is any substance that generally lacks the predominance of metallic properties, e.g. oxygen, nitrogen, iodine, chlorine, carbon, hydrogen, etc. Now, the non-metals are, when they say they lack predominance of the metallic property, in essence, they do not allow the flow of electrons. They don't have ionic bonds. They don't have these things. They are negative in nature. You know, they are not positive. I told you that the metals are positive charge. These ones are negative in nature. Negative. So when they bond with a metal, they produce a negative charge. When they bond with a metal, they produce a negative charge. In essence, that particular substance that they form with a metal becomes negative. Take, for example, hydrochloric acid. Hydrochloric acid has a negative sign. That's a negative charge. Why? Because of chlorine. Hydrogen too is negative. But hydrogen is equally positive and negative. It is the smallest diatomic atom. It is the smallest everything. The hydrogen, the H plus is the proton. The hydrogen ion is the proton. So in essence, hydrogen is both positive and negative. That is why it can react. It reacts with all the elements in the periodic table. Every element in the periodic table can react with hydrogen. Why? Because it has these two charges. It has a positive charge and a negative charge. Okay? Let me just take, for example, he's a free giver. So these non-metals do not have the properties of metals. They are not positively charged. They don't form ions, nothing. So they don't form positive charge ions. So this not anything that do not do that is a non-metal. Now the next class of element is the metalloids. We say metalloids are elements that are intermediate in properties between the typical metals and non-metals. Example, the boron, silicon, acetic, germanium, tellurium, antimony, etc. If you look at the pictures, you see them there. Okay, these are examples of metalloids. Now, when they say intermediate, they are in the middle. You know, sometimes they exhibit the properties of a metal. Sometimes they exhibit the properties of a non-metal. They are free, they do not overstand where they are. If it's in water, we will say they are warm, because they are neither hot nor cold. So these metals, according to their reaction determines their class. Their reactions with other metals determines their class. If they react, sometimes they can react with a metal, they can determine it to give them a metal. If they react with non-metals, then they are non-metals. So their reaction with these other metals determines where they belong. Like I said, they are in the middle. They are neither here nor here. So these particular metalloids are those elements that do not understand themselves. Okay? They don't form readily ions in most cases. They still do not form negative ions in most cases. So they are just there, determining on where they want to go to. You know, anywhere you push them, they go. So you've known the classes of elements. Like I said, we'll talk about these things very well when we get to the periodic table. We'll talk about the elements. Then we'll get to metals and their compound. We'll talk about metals very well. So just follow up, like I said. So the next one is the physical differences and properties between metals and non-metals. Physical differences. Okay, differences that are seen, differences that can be noticed. They say metals are good conductors, while non-metals are bad conductors. In essence, this metal is good conductor. I told you a conductor is a material that allows the free flow of electric current or the free flow of electrons from particle to particle. If it does not go from particle to particle, it's not a conductor. If you don't add that particle to particle, it's not a conductor. Some people will tell you a conductor is a material that allows the free flow of electron or allows the free flow of heat. No. Heat can be transferred from the pot to the water. That does not mean it's a conductor. Heat can be transferred from pot to the water. That does not mean it's a conductor. If I put a clay pot on the fire, is the clay pot a conductor? The clay pot is not a conductor. But heat has been transferred from the clay pot to the water inside. So how can you tell me that a conductor is something that is allow heat to flow? No. That's what I see in some books. So, like I said, it's from particle to particle. Example, if you put a copper wire from one particle, which is a socket, to the ball, which is another particle, the flow, there will be a flow from that socket to the wire. The copper will allow the electric current to flow inside the socket directly to the bulb. That is a conductor. You know, it is a medium where electric current passes through from particle to particle. Now, while the non-metals are bad conductors, electric current do not flow through them. You can't use oxygen as a conductor. You can't use chlorine as a conductor. No. So the next one is metals have high density, whereas non-metals have low density. Mostly, non-metals are gases, mostly. And we know that one of the characteristics of a gas is that it has low density. And metals are solids. And we know that one of the characteristics of a solid that it has high density. I've told you what a high density is, and I've told you what density is in our previous class. Now, non-metals are not malleable, while metals are malleable. Malleable means you can twist them anyhow. Okay? You can twist them anyhow. Like in the sense of gold, I can bend gold to give me chain. I can still refine it to anything I want to refine it if heat is applied. But non-metals cannot be bent. You cannot bend the oxygen. You cannot bend nitrogen. You cannot. Because it is something you can't even hold them to start with. While these metals are malleable. Okay? They are malleable. You can bend them to any form you want to use them. You can see the chairs, iron chairs that we have in our houses. You know, they bend them to the design they want them to be. That is why they are metals. Anyhow you bend them, they follow you. You know, they are malleable. They can be friendly to pressure. Now the next one is metals have high boiling point and melting point. Why? Non-metals have low boiling point and melting point. You know, because they're rigid, their boiling point will be high. Take, for example, you went to the market, actually, and you bought beans. Take, for example, beans is hard. Okay? Beans is very hard. Now, that beans that is very hard, if you boil the beans, you see that for the beans to be soft, it must have to have a high boiling point. Sometimes when the water is boiled 100 degrees centigrade or 212 degrees Fahrenheit, that does not mean that the beans will be soft. The water must have to boil, sometimes above its boiling point, before the beans will be soft. But if you just put water on the fire, which is a non-metal, at 100 degrees centigrade, the water is boiled. Okay, let's take, for example, a non-metal like oxygen. I want to combine it with hydrogen to form water. In less than 70 degrees centigrade, I've seen water. I don't need to wait till 100. So their boiling points are low and their melting points are low. Why? Because they are not rigid. If they are rigid, their melting point will be high and their boiling point will still be high because they are not rigid, they are not solids. And we know that solids have high boiling point. Solids have high melting point. Now, whereas the non-metals, which are liquid and gases, have low boiling and low melting. Now, non-metals are brittle and soft, but metals are rigid and strong. Like I said, they are rigid and strong because they are solid. This one are brittle and soft because they are gases and liquid. Now, they say metals are ductile and sonorous, while non-metals are not sonorous. They are not really friendly. Okay? Metals are ductile and sonorous, while these other ones are not ductile and sonorous. Now, let's go to the chemical differences between metals and non-metals. Number one, we say metals are electropositive, while non-metals are electronegative. I explained that to you when I was talking about metals. Okay, these metals are electropositive. In essence, the electrical charges are positive, while the non-metals, the electrical charges are negative. They are positive, while the non-metals are what? Negative. In essence, the metals are conductors, while the non-metals are not conductors. Now, metals form basic oxide with oxygen, whereas non-metals form acidic oxide with oxygen. Now, metals, okay, are positively charged. Now, when they react with oxygen, negatively charged, they will produce a negative charge substance. Okay, this basic oxide are oxide that when react with water emits negative charges, emits bases. You know what a base is. Bases are electrons. Okay, they are electron donors. When we get to acid, base, and salt, we'll scrutinize that. The bases are electron donors. In essence, they are negatively charged. So these metals form negative charges with oxygen. Like I told you, take for example, let's say now I want to react a metal with oxygen. Okay? I want to react a metal with oxygen, and I'm using sodium as a case study. Okay, I'm using sodium. Now, sodium oxide. Now, when sodium reacts with oxygen, okay, maybe with hydrogen too, it will give you sodium hydroxide. It will give you sodium hydroxide. And sodium hydroxide is negatively charged. Now, sodium hydroxide is a base on its own. And I told you bases are negatively charged substances. They produce electrons. So this is what this is one of the chemical characteristics of a metal. Now, with the non-metal form acidic oxide with oxygen. Take for example, the non-metal carbon reacting with oxygen to give us carbon dioxide, acidic. I told you a basic oxide are oxides that when react with water emits a base. Now the acid, when reacts with water, emits acid. The acidic oxide, when reacts with water, emits acid. In essence, when they react with water, they produce positive charge, while the metals produce negative charge. Okay? Now, when this carbon dioxide reacts with water, it produces a positive charge. It produces a current. Okay? Now, the next one is non-metals exist in all three states, solid, liquid, and gas. But metals are always solid. A non-metal can exist in a solid. You're surprised. Solid are metals. But a non-metal will exist in a solid. I want to give you an example. Mercury at room temperature is a solid, but it's a non-metal. Mercury at room temperature is a solid, but he is a non-metal. So you can see. Now, the liquid mercury is mercury already. Now, when mercury is being heated, it turns to gas. As you can see, I use mercury as a case study. When mercury is heated, it's a gas. When at room temperature, is a solid. Now, his nature is a liquid, but he is a non-metal. So it has existed in three states of matter. Now, the next class of matter is a compound. Is a compound. Compounds, as you can see on the screen, there's a reaction for the formation of compound. There's a reaction. Every single chemical reaction forms a compound. As we talk about chemical changes, you know, not all chemical changes result to the formation of compound. Not all chemical changes. It's just that a chemical change is not reversible. So when you see a chemical change, it does not mean that it must form a compound. Compounds are basically formed through chemical reactions. We know compound is a chemical change, yes, but it's basically formed through chemical reactions because compounds are basically a combination of elements alone. Like a chemical reaction, a chemical change, like the rotten mango. The rotten mango is not a compound. Okay? The rotten mango is not a compound. It's just a chemical change. Because the rotten mango cannot go back to its original form again. Now, these compounds you see are formed, like I said, with reactions, with chemical reactions. As you can see on your screen, there is a reaction. But before the compound was formed, okay, the physical reaction will take place before the chemical. As you're seeing it like this, okay, you're seeing it that the liquid is boiling because of heat. Okay, it's just the combination of this is the formation of hydrochloric acid. Okay, the liquid is boiling. The hydrogen is being changed to liquid to pour into the chlorine as a liquid, and it gives us hydrochloric acid. So now these compounds are being formed with the breakage of bonds. Bonds must have to be broken before a compound will be formed. You will know that very well in chemical combination. Now, when let's take for example, the hydrogen and the chlorine, like I cited, the hydrogen has a bond, the chlorine has a bond. The hydrogen is a molecule, the chlorine is a molecule. Now, they have their bonds because they have things that guided them. They have particles that made them this particular substance that they are. Now, those particles must have to break. Those particles are the atoms. Yes. So those particles must have to break. When this one breaks and brings what it has, the chlorine breaks and brings what it has, they will join together and form a new substance different from what they are. And that substance is called a compound. Let me give you one example. You and your brother wants to cook soup. Okay? Your brother, both of you, your brother must have to break himself to bring out 50 naira. You must have to break yourself to bring out 50 naira. No matter how it is, there must be breakage of bonds. If you like, you bring 50 naira, your brother brings 200 naira. Both of you brought something together, and you cook that soup that you will eat. Now, let's take your brother is the hydrogen about 20 naira. You are the chlorine that brought 30 naira. You brought together and you've cooked a soup. That soup becomes a compound. So that is how a compound is being formed. Now, what is a compound? A compound is a phenomenon that consists of two or more elements chemically combined together. Like I told you, that compounds are from the formation of elements alone. If you check, we see water, hydrogen and oxygen. We see sodium chloride, sodium and chlorine. We see ammonia, nitrogen and hydrogen. As you can see on the screen. Okay? And you see their formulas. 2 hydrogen, 1 oxygen, H subscript 2O, 1 sodium, 1 chlorine, NaCl, and 4 hydrogen, 1 nitrogen, NH4. NH subscript 4, sorry. So, you must have to understand, like I said, it is a phenomenon. It cannot go back. It cannot be separated. In that sense, it is chemically combined. It cannot be separated. Hydrochloric acid, water, sodium chloride, etc. It cannot go back to its original form because the constitution of these two elements have been binded chemically. So there is no, like I said, elements. Since the elements cannot be splitted into smaller substances, any stuff made up of this element cannot be splitted too. You should understand what I said. If the element, because we said element is a substance that cannot be further broken down by any chemical process. In essence, anything that constitutes this element, anything that comes to partake in this element cannot be broken too. Okay? Now, if, let's take for example, if I don't have sickle cell, any issue that comes from me will not have sickle cell. Any issue that comes from me will not have that sickle cell. So, a compound cannot be broken down or cannot be separated because the components cannot be separated. And the components are the elements. Now, what makes a compound is because it is different from the elements it's being composed of. That's a different species. It's a different species from the element it's being composed of. Hydrogen and oxygen came together, 2 gases. The next thing we saw is a liquid, water. So, hydrogen and chlorine came together, 2 gases. The next thing we saw is a liquid, an acid. So this is how a compound is. Breakage or bond must have to take place. Now the next one is the properties of a compound. What are the characteristics of a compound? Now we said in the formation of a compound, the elements lose some of their properties and the compound has a new property other than the reactants. Like I told you in the matter part 1, that reactants are substances that undergo chemical changes to form a compound. So the formation of a compound, the elements lose some of their properties. Like I told you, there will be breakage of bonds. So as their bonds are broken, their properties are being loosed. What are their properties? Hydrogen is a gas, oxygen is a gas. This is the physical property of hydrogen and oxygen. Okay? When they come together, they form a liquid. In essence, their characteristics are being disturbed. It has changed from being a gas to a liquid. This is the characteristics. And new properties other than the reactant. The new property now is the liquid. The product is now a liquid. It is a new property different from the properties of the elements that formed this compound. Now, elements are combined chemically to form a compound. I told you that the chemical reaction is a transformation. In essence, they transform, they transcend from point A to the production of point B. When these elements combine together chemically, they will not form the same substance that they are made of. They won't. It's like I brought cassava. Okay? Let's say I brought cassava. Now, me bringing cassava, I brought cassava and, okay, let's take for example, I brought fish, meat, everything, egusi, everything. I brought all of them together. And I put it on the fire and I boiled it. The name you give me, the name you will give to that thing is egusi soup. You will not say meat soup, or you will give it one particular name, egusi soup. That's the same thing. Okay, that is the same thing. When I put hydrogen and oxygen together, it will give me one name, water. So elements combine chemically to form a compound. Their reactions are chemically because they must have to transform from being an element to being a compound. They must have to transform from being, they must have to change from the original state to another state. They must have to change from their properties and characteristics to a new property and characteristics. Now the last one is the compound may possess different melting and boiling points as compared to the reactant. Yes. Let's take, for example, hydrogen has a boiling point of 40 degrees centigrade. Oxygen has a boiling point of 30 degrees centigrade. Bring them together, water. Water cannot have hydrogen's boiling point or oxygen boiling point. Water is going to have a boiling point that is different from both of them. Why? Because both of them do not have the same boiling point or melting point. Now, the next class of matter is the mixture. If you look at a mixture, you see that it is only one product that is being formed when two substances are joined together. Like we said in the physical change, before a mixture will be formed, one must have to be a solute and one must have to be a solvent. And these mixtures are called solutions. Okay? When they are being put together, as you can see there, the sugar is being put inside the water, and a mixture is always done by mixing. That's why it's called mixtures. Mix them. Mix the people. You know, you must have to mix them. Okay? The mixtures are done by mixing. Now, mixtures categorically are solutions. And I told you that a solution is a combination of two or more substances to form a single product. Single products are being formed. One thing is being formed during a mixture. And if the particular thing does not dissolve very well, it cannot be a mixture. If there's a separation, it will be a mixture, yes, but it will not be a real mixture. We will know types of mixture. When we talk about types of mixture, we will know that now. So I said the mixture is done by mixing. And this mixing, one must have to be a solute or a solvent. Now, most times people feel solutes must have to be solids. No. It's not a must that solute to be a solid. Anything that dissolves in a liquid is a solute. Take, for example, an acid. An acid dissolves in a liquid, a base. It dissolves in a liquid base, sodium hydroxide, to form salt and water. So solutes are not necessarily solids. It's only solvents that are necessarily liquids. Every solvent must have to be a liquid, but not every solute will be a solid. Take note. I've told you what a solvent and a solute is. Okay, anything that dissolves in a solvent permanently is called a solute, or completely is called a solute. Anything that a solute dissolves in completely is called a solvent. Now, what is a mixture? A mixture is a combination of two or more substances that is physically combined. It is physically combined. Air, crude oil, sugar solution, soil. The air is physically combined. Physically. Inside the air, we see nitrogen, we see oxygen. They can be separated. Even when you're breathing. You know, when you're breathing, you separate the air and you take in only oxygen. It is a miracle of nature, curiosity. So, the crude oil too is the mixture, because inside crude oil, you get petrol, you get everything. And it is being done by separation. We will know that in the separation technique when we talk about crude oil. Now, if you check on your screen, the sugar solution, you see water and sugar gave us a solution. The sugar dissolved in the water and it gave us a solution. And that solution is called a mixture. Why? Because it is physically combined. You did it by yourself. It is something that you do. It passed no process. Okay? It passed no heating, no energy. You did it by yourself. Now, the next one is types of mixtures. So let's look at the types of mixtures. Types of mixtures, we have homogeneous mixtures and heterogeneous mixtures. Homogeneous mixture is a mixture that has the same proportion of its components throughout the given sample. Now, the given sample is the product. The given sample is the solution formed from the mixture. Now, if you look at the salt solution as a case of study, if I put a salt inside water, okay, the salt will change to a liquid automatically. Why? Because it has dissolved and accepted the salt, the liquid, which is the water. So it is now a solute because it dissolved in a solvent completely. Now, it's going to give me only water. It has given me one proportion. It has given me the same proportion of its components. What is the component? The component is salt and water. Putting them together, it gave me one proportion, the same proportion, which is the salt and the water. So, if I take this water, that salt solution, to London, what the person will tell me is that it is water. Because he would not know the amount of salt inside the water, mere looking at the water physically. Even if you separate it, you will not know the amount of salt that is inside. You just have to separate because some salt will definitely evaporate with the water. So, this component, as long as they are the same, when the product is being formed, it's called a mixture. Because the amount becomes the same. Now, it's called salt solution. If you check, there is no amount of salt in the particular product, which is a mixture that is being formed during this particular physical process. So, in that solution, the salt and water becomes one. It becomes one. It is not separated. It is not two. The only way you can separate it is except you apply a separation technique, and the proportion will never be the same. Example, air too. In the air, if you look at the air, the air gave us only one thing. Most people feel that oxygen is the only thing that is applicable in the air. No, there are so many gases in the air. It is only when you're breathing the separation occurs. Okay, so now the air is just the same. You cannot tell if there is nitrogen, oxygen, carbon dioxide. You can't tell. Carbon, you can't tell. The only way you can tell is when you want to separate. But it gave us one proportion. Every single gas in the air gave us one proportion. The same thing as air. It did not give us a different thing altogether. So this type of mixtures, that when they come together, they give you one particular proportion, one particular thing. Now, take for example, if the liquid is 10 kilograms and I put a salt inside, if I weigh that liquid, it's going to give me 10 kilograms. Because what I'm going to weigh is the water. Because the salt has been mixed with the water. The salt has taken the properties of the water. And one of the properties of the water is a liquid. Is that it is a liquid. So the salt becomes a liquid inside the water, and it gives me one proportion. While the oxygen gases, all of them becomes one particular thing, which is air. Now, the next one is heterogeneous mixture. It's a mixture where throughout the solution, the composition is not uniform. Sand and water. When you put sand into water, you see that the sand goes down. And there is a barrier. There is a separation between the sand and water. Even if you mix them together, it will still be like that. The sand do not accept the properties of the solvent. Remember, a mixture or a solution will be achieved when the solute accepts the properties of the mixture, of the solvent. So in this case, the solute do not accept the properties of the solvent, which is water. So in essence, the sand is not a solute. But both of them can be put in one place. But when they put them in one place, the separation will be there. And you know that this is a heterogeneous. Heterogeneous means so many. Now, ice cube in a drink. Why ice cube in a drink is not a homogeneous mixture is because I know that you will say ice cube is a solid, yes. But the ice cube, its nature is not a solid. That's not its nature. Its nature is a liquid. It only turned to solid because of a process called freezing. In essence, that ice cube is a solid that changed to liquid. And that is why every liquid can exist in the three states of matter. Every liquid can exist in the three states of matter. The liquid is the liquid state already. By freezing, it becomes a solid, and by evaporation, it becomes a gas. We'll talk about that in the kinetic theory of matter. So the ice cube now is a solvent already. Two solvents cannot form a solution. I told you that for a solution or mixture to be acquired, one must have to be a solute and the other a solvent. So the ice cube, when you put it into a drink, it becomes the same as the drink because it is water. So water and water cannot form a solution. Now, salt and oil. When you put salt into oil, okay, it does not dissolve. Put your hand inside the oil, you feel the particles of salt. So in essence, it did not dissolve. So there is still a separation between the salt and the oil. We have come to the end of this section of this class, or for today. But before we leave, we must have to use our exam guide to guide us in what we have learned, to quantify the lesson you have taken. Now, the first one is in the WEAC. We will take the year 2000, question 9. Question 9. 2000, question 9. Let's get started. Question 9. Question 9 says, which of the following non-metal reacts most readily with metals? I told you in the introduction of the elements, I told you that there is a particular non-metal that reacts with every metal in the periodic table. I called a particular non-metal for you, and I told you that it is chlorine. Chlorine reacts with most metals. I gave you an example of sodium, okay, forming sodium chloride with chlorine, which is the common salt. So the answer there is chlorine. Now, let's go to another question. An element which can exist in two or more forms in the same physical state exhibits, I told you about that again, that an element can exist in two physical states, and I cited an example of oxygen. Oxygen is a gas, okay, as its physical state of matter, but it can still exist as a liquid when it reacts with water. I gave you an example of that, and I said it is called allotropy. It is called allotropy. When these elements have two or more physical states, it is called allotropy. So the answer there is C. The correct answer there is C. Now, let's go to the last question. Now, question 1 says, allotropes are elements differ in their. I told you of allotropy and allotropes. So those elements that experiences allotropy are called allotropes. Now, I told you that this particular allotropy will give you the same chemical property. Oxygen is the same. If you do with the same chemical property, oxygen can react with hydrogen to form water. Oxygen is a non-metal, the same chemical property. But the physical property changes. It is different. Why? Because oxygen as a physical state of matter is a gas. But when it reacts with water, or when it reacts with hydrogen, becomes a liquid. So in essence, it is the allotropy tells you the difference between their physical states. Because allotropy is when a metal, or when an element, exists in two or more physical states. So in essence, that physical state must have its physical property. And the physical state will be different because it exists in two or more. That means it must have to be different. So the answer there is it is different in their physical properties. Because the oxygen has been different in the physical property that he is a gas. That's his physical property. Now change to a liquid when it reacts with water. So the answer there is physical property. Thank you for participating in today's class. You can practice more questions using the ExamGuide app. The app scores and gives a detailed explanation of all the questions at the end of your practice test. You can learn a particular topic of interest with different modes like study mode, mock mode, and practice mode. It also has other features that make learning fun. It is a must-have for all serious students. Download from www.examguide.com if you don't have it yet. See you in the next class. Don't forget to subscribe to our channel, hit the notification bell, and share the videos to people that will benefit from it. Bye.